Okay, folks, here we go with problem 625. Same idea, but notice right up front that the data is being presented to us here a little bit differently than it has been in the past. What we've got here is we've got 3 years of data, and it's reported to you by quarter. So the first thing I have done to get started here, for now you can ignore columns C, D, and E. That'll come in during part B. So I've listed let's see, first year, second year, third year, first, second, third, fourth quarter, so on and so forth. And then what I have done is I have translated each one of these combinations of year and quarter to time period 1 through 12. So just so you understand the sequence here, year 1, quarter 1 is time period 1, year 1, quarter 2 is time period 2, so on and so forth. And then I have also listed the dependent variable here. Not quite sure what that's measuring, but this would be kind of the approach that you would have seen on problem 6.5 or 6.19. Let's see, first thing we want to do here, we want to look at the time series plot. And again, what you would be doing is you would be plotting this set of ordered pairs, and I believe it's plot 3. And notice while you got sort of a horizontal approach here, there is sort of a seasonality trend going on in here. That's something that's discussed in your reading. This idea of level, trend, seasonality, certainly want to pay attention to those this week as you kind of focus on the concepts of forecasting. Let's see. Let's see. So plot 3, horizontal pattern, yes, with seasonality. So that is basically the appearance of the data. And so remember I said when I talked to you about 6.19, I said there's a couple different ways that Excel will perform regression. If you have simple linear regression where you have just one independent variable, you can do that graphically, or you can use the data analysis tool pack with regression. And but when you get into a case like this where we're going to have more than one independent variable, again, effectively a multiple regression situation, we're going to have to use a data analysis tool pack since we are not able to do this graphically. And so let's see, remember I said C, D, and E, let's hold off on those. This is where those come in. Let's see, it says use a multiple regression model with dummy variables as follows to develop an equation to account for seasonal effects in the data. It says quarter 1 will equal 1 if quarter 1, and then it'll be 0 otherwise. Quarter 2 will equal 1 if quarter 2, 0 otherwise. And quarter 3 will equal 1 if quarter 3, 0 otherwise. So what we're saying is this, if we look at these by row, and again, we want a dummy variable for quarter 1, 2, and 3. If we're in quarter 1 in the dummy variable will be 1 and 0 otherwise. If we're in quarter 2, notice that quarter 2 is equal to 1 and then 0 otherwise. And then if we're in quarter 3, the dummy variable for quarter 3 will be 1 and then 0 otherwise. So that gives us this scheme for the dummy variables that we need here in order to come up with estimating slope and coefficients for each one of the variables here. And so once we have done this, we're able to get the regression results. Let me delete these because I want to develop them again for you. So let's see. In order to use the analysis tool pack, if you go up here to data and go to data analysis, excuse me, one of the options in the data analysis tool pack is regression. So if you just click on regression, yeah, it's still got my old data. Let me just zero this out. So I'm starting from scratch here so you all know exactly what I'm doing. A18, let me remember that. So remember, whenever you use this data analysis tool pack, the first input is the dependent variable. And so the dependent variable is, again, I'm not quite sure what we're measuring, but it's this YT. The input range is going to be the dummy variables and the time variable. So we're just going to make sure that our cursor's in the input X range, independent variable. We're going to get the tags. Yep, tags and all the data scrolled in here. So we've got the y variable, the independent variables, all four of them. Notice that I've got the labels box checked here because I have labels, and this will help me interpret or just make sure that I'm very clear when I interpret the regression results. If you click on output range and then just click a cell in the sheet, remember I put this in A18, this should produce the handy dandy regression results. And what we're interested in here, so that we can make our estimate, is we want to go down here into the coefficients results. The intercept, again, if this was just a regular XY plane, the intercept would be the point where the line crosses the vertical axis. But notice here, what we are interested in order to build this regression equation is we want the intercept, and then we want the coefficients for quarters 1, 2, and 3, and then the time period. And so if you look at this piece right here, what I'm doing is I'm pulling off here to develop this equation. And remember, a regression equation is y hat, or an estimated value. I'm going to throw the intercept in here first, so 3.417 plus 0.219 B1 minus 2.187. I rounded that up to 8. And then minus 1.59, yeah, I rounded that up to 4, B3. And then plus 0.406, yeah, that's 406 T. And I believe this is, I don't believe 625 is algorithmic. So we all should be producing the same results. And I believe what I have here matches the results over here. Excuse me. Compute the quarterly forecast for the next year. So what I have done down here, so quarter 1, quarter 2, quarter 3, quarter 4. And since I ended on time period 12, the input for each one of these variables, B1, so on and so forth, will be for this particular estimate. You'll be inputting. Let's see. I should say for the time period. The time period will be 13, and if it's quarter 1, remember in quarter 1, B1 will be 1, B2 and B3 will be 0. When you get to quarter 2, B1 will be 0, B2 will be 1, B3 will be 0, and T will be 14. When you get here, same thing, 0, 0, 1, 15. And then quarter 4, all 4 of the B1 through B4 values will be 0. Let me just do one of these for you here. Equals 3.417 plus 0.21 plus 0.219 times, since that's quarter 1, that will be 1, minus 2.188 times 0, minus 1.594 times 0, plus 0.406 times time period 13. And hopefully we come up with a value of 8.92. We come up with 8.91. We're off by a tenth, hundredth, thousandths. My hunch is when you put these into Excel, or when you put these into Cengage, that they are not going to give you a hard time. Just for the heck of it, let me try this as well. Instead of using the rounded values, let me go up and get the actual values from Excel and see if we can get 8.92. So equals, let's see, the intercept plus this coefficient times 1 plus this coefficient times 0 plus this coefficient times 0 plus this coefficient times time period 13. Let's see if we can get 8.92. Yeah, that's exactly the way. So that's good. So when you write the equation, when you put in the values for B0, B1, B2, B3 to answer the question in Cengage, I think you can round these. Let's see, required to 2 decimal places. Actually, sorry. I'm looking in the wrong spot. For B, you can round these values to 3 decimal places. That's fine. When you do the actual forecast, notice how I did that. I just picked the values right out of the regression results. I don't have to type the values. I can just type the cell reference. You can pull this down actually, and then I think what you're able to do is you're able to just go back in here and change the value. So that should be 0, that should be 1, that should be 0, and this should be time period 14. Hopefully get 6.92. Well, what did I mess up here? B35. No, that should be B34. Actually, what we have to do, let me just do this real quick and show you. And you'll have it in here. All you have to do is put dollar values in front of each one of the alpha and the numerics. That way, when we pull the formula, this won't change. So I'm building the airplane for you here, folks, as I fly, but I think this will be helpful for you to do this computation. See a dollar figure there. All right, so hopefully, let's see, what we're looking for is 6.92 here. Let's make sure that we change. Let's see, this should be, again, this should be, since we're in Q2, that should be 0. This should be 1. This should be 0. And this should be time period 14. And there is 6.92, right? So you can do this, just pull this down. And then for quarters 3 and 4, all you have to do is go back in and swap out the zeros and ones. So 0, 0, 0, 1, and then finally the time period. And we should have 7.92 here. That looks pretty good. All right. So I hope this is helpful. Just remember one more time, when you put in the answers for the let's see, for the intercept and then the coefficients of B1, 2, and 3, make sure you round those to 3 decimal places. When you compute the forecast, like I said, just use the actual values from the regression results. Don't use the rounded values. Remember, we were here we were off by about 1,000th, and I don't want that to hang you up as you're trying to get your numerical results into Cengage. So I hope this is helpful. If there's anything I can do for you this week, please let me know. Take care, God bless, and have a great week.